Okay, a company wishes to manufacture a box with a volume of 36 cubic feet that's open on the top, twice as long as it is wide. Find the dimensions that would minimize the amount of material. Okay, so here's what's important here. We're going to minimize the amount of material. And when we have amount of material, that's actually called the surface area. Okay, now a box looks like this. Now let's see if I can change it up just a little, fix it for you. Drawing 3 dimensions, not really my best skill. Okay, but when you think of this particular box, we want to talk about the surface area of it. And what the surface area is all of the areas of all of the sides added together. So this particular box has 3 different measurements. It has the length and a width of the bottom. Okay, so let's color in that shade. So here's your bottom, and that's the length and the width. So this top piece here also has a length and a width. So the way that they get the formula for surface area is they say 2 times the length and the width. So that gives you the top and the bottom of the box. Okay? Now, this box also has another measurement, and that's height. So this is my height. Now I want to take this side of the box for just a second. What you'll notice about this red side of the box is its width and height. Okay, that width and height will also be this end of the box as well. So if you look at that one, you would have 2 width and heights. Okay, so then there's 2 sides of the box that aren't mentioned. So let's take this front side of the box. It's a length and height. So this front side of the box is length times height, and that of course also means that the back side of the box is length times height. So that is your surface area formula, and that's how they acquire the surface area formula. Now, this is the surface area of all boxes, but our box is special because if you read on there, it says it is open on the top. So that means it doesn't have a top. So let me erase this blue part for a second. It doesn't have a top. Let's see if we can draw it back. Okay, so since it doesn't have a top, that means one of the blue pieces is gone, and the formula we're going to use today is length width plus 2 width height plus 2 length height. Now, inside the surface area formula, you have 3 variables, L, W, and H. You can't use all 3 of those, so you have to narrow it down to get 1 variable using other facts. Okay, so let's see what we can do with that. Now then, let's read through there. It says, first of all, that it has a volume of 36 cubic feet. Well, the volume of a box is length times width times height, and it tells me that the volume of my box is 36. So we're going to need to use this fact at some point. It also tells me that it's open on the top, which we already considered. It's twice as long as it is wide. So that means the length is twice the width because it's twice as long as it is wide. So that means that you have length equals 2W. Now, so everywhere in the problem that I see an L, I can put a 2W in that place. So that means that this part right here will be 2W, and that this part here will be 2W, because length is 2W. Now, I have to turn the height into W as well. So let's go back over here to my volume. I know that length is 2W. So going to this function over here, I have that 36 equals 2W squared H. So if I'm looking for H, I can divide both sides by 2W squared. And H would be 18 over W squared. So everywhere I see an H, I can put 18 over W squared. Now let's clean that up. So I have that the surface area equals 2WW, which would be 2W squared. Okay, so this next one I have 2W times 18 over W squared. We'll clean that up in a minute. And for this last one I have a 2 and a 2W, so that's 4W times 18 over W squared. Okay, let's keep cleaning it up. So we have 2W squared, 36 over W, this would be 18 times 4, 72 over W. And you'll say, now where'd you get that? Well, remember you have one W in the top and 2 in the bottom, so that's where I left with 1 on the bottom, and 4 times 18 gives me 72. Now it cleans up one more time because we have a common denominator. If I'm adding these W fractions, I have a W and a W, so add across the top, and I get 108. This is the formula for which I want to maximize. Surface area equals 2W squared plus 108 over W. Surface area equals 2W squared plus 108 over W. Now, I can't take the derivative like that. Move the W to the top. Now I can take the derivative. So I change that W, I'll bring it to the top, and of course that makes its exponent negative. So let's take the derivative, and we get 4W minus 108 W to the negative 2. Because remember, you'll say negative 1 minus 1. So we're going to get 4W minus 108 over W squared. And that's my derivative. Now, we need to get a common denominator. So remember, to get a common denominator, it's going to be W squared. So if I put a W squared here, I have to also put a W squared here in the top. So what I'm going to get is 4W cubed minus 108 over W squared. Now we need to see where this derivative equals 0 and where it's undefined. So it equals 0 where the top equals 0, and it's undefined where the bottom one equals 0. So I have a critical number at W equals 0. We'll solve this other side out. Let's see, 108 divided by that will go 4. Wow, a nice good number. I wasn't expecting it. You'll see that you have a cube here, so make sure you take the cubed root and not the square root. So if you take the cubed root of both sides, you would get 3. So I got that W equals 0 and W equals 3. Now one of those two is going to optimize this expression. Remember, my values are 0 and 3. Let's go back. Okay, the formula for which I have to optimize is this one here in blue. Well, I know that W can't be 0 because if W was 0, I would get something that's undefined here. So I don't have to worry about W being 0. So that means that W being 3 is going to be my answer. So the surface area, the maximum surface area, would be 2 times 3 squared plus 108 divided by 3. And 18 plus 36 would be 54. So 54 would be my surface area. But that wasn't what the question asked. Make sure you answer the question asked. It only asks you to find the dimensions of the box. So the dimensions of the box with minimum surface area would be when W was 3. No, that's not your answer. I need all the dimensions. So not only do I need W, I need L, and I need H. So go back across the far side for a second. If W is 3, length would equal 2 times 3 right here. So length would equal 6. Okay, let's go back over here to H. If W equals 3, H would equal 18 over 3 squared, 18 over 9, which is 2. So this particular question asks for dimensions, 3 by 6 by 2. If it asked you for the minimum surface area, if it asked you a second question, you could just plug that in and you would get 54. But this particular one did not ask for the surface area, just the dimensions.